So question 1, we've got getting the blackboard ready. Let's get a nice little pen going. Let's go for white. So we've got sec x minus tan x sine x, and we've got to make it into 1 over sec x. So we know that this is 1 over cos x. Tan is sine over cos, and times sine. So on top we've got a common denominator here of cos x, we can put them both over cos x. On top we get 1 minus, and sine times sine is sine squared. And 1 minus sine squared here equals cos squared. And cos squared over cos equals cos x, and we know that cos x is 1 over sec x. And that's a little QED, quadrate demonstratum. Let's get new blackboard up. There we go. We'll do question 3 here. Got it in the wrong order, but not to worry. So, sorry about that. We'll do question 2 in a minute. So we got sec theta sine theta over tan theta plus cot theta. And we're going to make that equal to sine squared theta. This is not very easy, this one, but we'll see how it goes. So we know the top is 1 over cos theta times sine theta, and the bottom, what we could do is turn everything into sine and cos again. See if that works. Sometimes you can try things and they don't work. Sometimes you try things and you go a different path afterwards. So on top now I'm going to look at these two here. I know that so this becomes sine over cos. And on the bottom here, I'm going to make a common denominator of these two here. And that common denominator is cos theta sine theta. We know that when we do this, we got division, so we're going to do that divided by that. Gives me sine theta times the sine theta makes sine squared theta. This is just adding simple fractions. And then I'm going to do this again divided by this one, gives me cos theta times the top here, gives me cos squared theta. Well, that's quite interesting because that gives me sine squared plus cos squared, which you know is 1. So we've got now sine theta over cos theta over 1 over cos theta times sine theta. Whenever we divide by a fraction, we multiply it by the reciprocal, so we're getting close here. Times cos theta sine theta over 1. And something's going to cross out here. The two causes can cross out. And we do indeed get sine times sine, which is sine squared theta. And we've solved it. Well done, Mick. So we're just going to do question 2 and 4 now. So let's just do a little blackboard here. So we've got this is question 2 here, 1 plus cos x over sine x equals cosec plus cot. This is quite easy, this one. All these should be remembered, just practice them over and over again. What we've got here is a fraction. We can split this fraction up, so we can say it's 1 over sine x plus cos x over sine x. It's called splitting the fraction up. And I'll just give you an example of where it works with numbers to show you. If we had 8 plus 2 over 5, we know the answer's obviously 2 because it's 10 over 5, but we can split it up. We can say it's 8 over 5 plus 2 over 5. We can split that fraction up. And we know we can do that. That's easy. So coming back here, What does 1 over sine x equal? Well, 1 over sine x equals cosec x. What does cos over sine equal? Equals cot x. And we've solved it QED. The next one, just getting a little blackboard up. Not sure how long this one's going to take, so I need the whole page perhaps. Sec theta over cos theta minus tan theta over cot theta. And this one should be easy. Well, it's going to be, we know that cos is 1 over sec. So it's times sec over 1. You divide by a fraction. Minus tan. And cot is 1 over tan, so when we divide by that we get times tan over 1. What we've done there is just put the extra step in. It's sec over 1 over sec minus tan over 1 over tan. And that leaves us with the next line. So we do indeed get sec times sec, which is sec squared theta, minus tan times tan, which is tan squared theta, and that equals 1 by one of our Pythagorean identities. So we're on the whiteboard now. So we've got cos x equals 5 cos x equals 0.7824. So we know that x equals cos negative 1 of 0.7824, and therefore x equals, we get 38.52 degrees. And then where is cos positive? We know cos is positive quadrant 1 and quadrant 4, and both of these angles here equal 38.52. So therefore theta equals 38.52 in quadrant 1, and theta equals 360 minus 38.52 in quadrant 4, which is 321.08 degrees. Question 6, we've got tan x equals negative 0.2314. So x equals tan negative 1, positive 1.2314, which equals 50.92 degrees, and therefore tan is negative in quadrants 2 and 4, so theta equals 180 minus 50.92, which is 139.08. That one's in quadrant 2, and then quadrant 4 is going to be 360 minus 50.92, which equals 308. In fact, that's wrong, isn't it? 309, I think it is. 0.08 degrees. So question 7, all about finding the two angles. So we've got ABC, two triangles, sorry. So we've got angle A is 50 degrees, side A is 8, side C is 10. So angle C, we've got to try and find two lengths of side B. So we know that 8 over sine 50 equals 10 over sine C, and if we move this along a bit, angle C should equal, so it's 73.25 degrees. So So therefore we've got the two solutions. Solution 1 is going to be A equals 50 degrees, C equals 73.25 degrees, and therefore B will be 123, that looks like 56.75, subtract from 180. Solution 2, let's see if it exists. A equals 50. C will be the supplement of this, that's 106.75. Straight away you can see that there is an angle B. Add those together, we get 156.
Maybe.
That
Michelle,
means 23.25 degrees. So we've got two triangles, and we know that for this triangle here, B over sine 56.775 degrees will equal 8 over sine 50, and B therefore will equal 8.73. And for this solution 1, that is, and for solution 2, we know that B over sine 23.25 equals, again, 8 over sine 50. And by cross multiplication, we get that B equals, and we get 4.12. So the two answers there, 4.12 and 8.73. Okay, question 8, 9, 10 should be fairly straightforward. We'll try and get through those as quick as possible. 8 is going to be a cosine rule, so we know that cos x equals adjacent squared. Let's see if we can put them in. So adjacent squared is 11 squared plus the other adjacent squared, 15 squared, minus the opposite squared, 10 squared, all over 2 times adjacent, and that will equal, let's go back to white, 121 plus 225 minus 100 all over 15 times 2 is 30, so 330 I think it is, yeah. So we've got 21 plus 225 is 246 over 330. That's what cos theta equals, cos x in this case. So cos x equals, we get 0.7455, 0.7455, and therefore x equals 41.8 degrees. Question 9 says find y. Again, we're going to use the cosine rule, so cos 100 equals 7 squared plus 11 squared minus y squared all over 2 times 7 times 11. So we know that cos 100 equals 49 plus 121 minus y squared all over, what do we got, 14 times 11 is 154. So I'm going to take that across and multiply, so we get 154 times cos 100 degrees. 49 plus 121 is 170, I believe. Remember, these two will switch places. So we get y squared equals 170 minus 154 cos 100. So when you go to your calculator, so we get 196.74, and we take the square root, and we get y equals 14.03. Ten's a good question. So we've got a mountain and an incline, 8 degrees. And then we've got a vertical pole. We've got to work out the length of these two, like ropes they are really, but doesn't matter either way. 20, and we know these are equal, 10 and 10. What you do know is that this angle in here is equal to this one, 8 degrees. So therefore this angle in here is going to be 90 minus 8, 82 degrees. And therefore this angle here is going to be 8 plus 90, 98 degrees. So therefore D1 will equal the opposite side, so therefore cos 82 will equal adjacent squared plus adjacent squared minus D1 squared all over 2 times 10 times 10, that's the adjacents. So cos 82 will equal 100 plus 400, which is 500, minus D1 squared, and this is 400 on the bottom here. So 400 cos 82 will equal 500 minus D1 squared, and switch the D1 squared over, 500 minus 400 cos 82 degrees, and we get D1 squared equals 444.33, and therefore D1 will equal 21.08 to 2 decimal places, 79 here. Now I think the only difference between D1 and D2 is that the angle is different, because you've got the 10 and the 20 are the same. So therefore D2 squared should equal 500 minus 400, and then the angle will change to 98 instead of 82. Instead of that 82, we just put the 98, and we will get D2 squared equals, and we get 555.67, and therefore D2 should be in the same region as 21.8. They're not going to be too far apart, and we got 23.57, so they're very close in length, just a subtle difference. Okay, that's the homework done. Well done.